Assalamu alaikum students. Now we are beginning our second video of this free fall motion. So here this is the famous Tower of Pisa that actually became more famous due to the experiment carried out by Galileo to prove that all the objects irrespective of their masses accelerate at the same rate. Okay, so falling objects, do they accelerate? Yes. They start from rest and they become faster and faster. And what about the feather? Of course, air resistance acts on this feather. That is why it reaches the terminal velocity, which we studied in our previous video. So if the air is not there, then what will happen? F is equal to ma, the force which produces acceleration. So that force is proportional to mass. So feather has less mass, so force acting on it is also less. But ratio of F over m will be same as that of the ratio for any cannonball. So in the absence of air, they will hit the ground at the same time and they will accelerate at the same rate. Now, mass versus weight. Mass is reluctance to accelerate, that is hindrance to the or opposition to the change in state of rest or of uniform motion in a straight line. So mass is inertia actually. Okay, and weight is the force of gravity exerted on the object. Okay, so moon has smaller gravity, so weight changes over there, but mass remains the same. So at the Earth's surface, all the objects experience same acceleration, and that is 9.8 meter per second square. And when we round it off, it's 10 meter per second square. So, but acceleration due to gravity for the surface of the Earth is 9.8, but for any other planet, it will be different depending on its mass. But acceleration due to gravity is there whenever there is a massive body. Okay, so like greater acceleration will be caused on the objects which will fall in on the surface of Jupiter, because greater Jupiter will have greater gravity due to its greater mass. So F is equal to ma, that is the gravitational force must be proportional to mass. So A will be constant. Golf ball versus this bowling ball. So which is more massive and which one will experience more gravitational force, and which one is the most reluctant to accelerate? How do they respond to the gravitational force? These are the questions which will be there in your minds. So if there is no air resistance, they all will be having same acceleration, and this bowling ball is of course heavier. So now consider two identical falling objects. Okay, so they fall at the same, they are separate and they fall at the same time here. Now imagine the two more balls which are connected together with any tiny thread. So they also hit the ground at the same time. The mass is m and this mass is 2m. They have the same acceleration. Force on joint mass must be twice the force on one of them. Okay, on one mass here is m, so on two masses which are joined, it will be 2m. So the ratio of force to the mass will be the same. So gravitational force must be proportional to the mass. So if the gravitationally induced acceleration is the same for all objects at the surface of the Earth, then the force exerted by gravity will be equal to mass into acceleration due to gravity. So F is equal to mg w, or this will be equal to the weight of the body, mass into this gravity. For a mass of 100 kilogram, the gravity on the surface of the Earth will be 980 Newton. Said another way, gravitational force is proportional to mass. F is equal to ma, give an object's responding acceleration, and divide both sides by m. So you will get A is equal to F over m. Both numerator and denominator are proportional to m if force is gravity. So acceleration is the same regardless of the mass. We all return to this point when we consider general relativity, which is not in your course to be discussed. Okay, falling objects accelerate. Ignoring air resistance, falling objects near the surface of the earth experience a constant acceleration of this 9.8 meter per second square or 10 meter per second square. That means if you drop something, it goes faster and faster, increasing its speeds downward by 9.8 meter per second in each passing time. Passing second means after every second, speed on the average will increase by 10 meter per second every second. And it acts on the bodies all the time. Whether body is on the ground, it is at the maximum height, it is moving upward or downward, it will always act vertically downward. Okay, so whether you throw it horizontally or give it a projectile motion, okay, at every time gravitational force will be acting, its value will remain the same. This is the projectile motion, and horizontal velocity remains constant throughout the motion, and vertical velocity keeps on increasing. But both the bodies, whether you drop vertically downward or give it a horizontal velocity, both of them will reach the ground at the same time. There are some exercises to be solved. Read them. A ball falls from rest for 4 seconds, neglecting air resistance, during which of 4 seconds does the ball's speed is increases the most. Of course, the last second. Okay, because speed increases by 10 meter per second every second. So it means 4th second its speed will be 40. Initial speed will be 0 because their ball is dropped from rest. Okay, this is another like doing with the numbers. Imagine dropping an object and measuring how fast it is moving over consecutive 1 second interval. And the vertical component of the velocity is changing by 10 meter per second in each second. And we take it as 10 meter per second square. Now doing some with the numbers now. First second, acceleration remains constant 10. Velocity at the end of the 1 second interval 10 meter per second. Second interval it's 20, then 30, then 40, and then it becomes 50. After an interval of t, the velocity changes by an amount at. V is equal to u plus at is used here. V initial and at. So every time it is increased by that amount. How fast was it going at the end of 3 seconds? So at the end of 3 seconds, it was going at a speed of 30 meter per second. Initial speed was 20 after 2 seconds and 30 after 3 seconds. So after every second, speed increases by 10 meter per second. So V is equal to, you can do it this way, like V final, if initial speed is 20 and acceleration is 10, V is equal to U plus at. 20 plus 10 into, what is the time interval? 1 second. 1 second, so answer is 30. You can do it by calculation also this way. Now again some more calculation. Acceleration constant, velocity initial 0, final after 1 second 10, initial 10, after 1 second 20. Okay, then at 2 second velocity is 20, and at 3 second velocity is 30, at 3 second velocity is 30, and 4 second it is 40. 4 to 5 increases from 40 to 50. What is the average velocity? How do you calculate average velocity? You add initial and final and divide by 2. So answer is 5. Okay, half V initial plus V final gives you average speed. For 1 to 2 interval, it is 5 meter per second. And 0 to 1 interval, it is 5. And 1 to 2, 10 plus 20 is 30. 30 divided by 2 is 15. Now again, acceleration is constant, final velocity, average velocity, and distance moved. So how much distance moved in the downward direction? It's given in meter. So in first second, 0 to 1 second, distance moved is 5 meters. In 1 to 2 second, distance which is moved is like in first second it is 5 meter, and next second it is 15. So total distance from rest, and at the end of 2 seconds it is 20. Then it is 45, 80, and this is total distance. This is after every interval. In first second it has covered 10 meters. In next second, first second it has covered 5. Then in next second it has covered 10 meters, and that next second it has covered 15. 25 minus 15 is 10, and the next second further 10, and then that next second further 10. So total distance which is covered here is 125. Okay, like first second 5 meter, 2 seconds 20, total 3 seconds 45, total 4 seconds, from 0 to 4 80, and from 0 to 5 it is 125. And that dealing with the unit meter per second square into seconds, acceleration into time gives you the unit of speed. A into t, v is equal to u plus at, that gives you unit of speed. So now this is the summary. Velocity refers to both speed and direction. Acceleration means change in velocity. Mass is property of object that represents their reluctance to accelerate. If an object is accelerating, it's being acted upon by some unbalanced force, and we calculate this force by F is equal to ma. All objects too suffer the same acceleration, okay, which is caused by the gravity, okay, whatever if there are masses. Okay, what are their masses? And gravitational acceleration only affects the vertical component of motion. Now let us talk about the graph. So this is the distance time graph for the free fall motion. Okay, distance time graph for free fall motion. In the same way, see, this is not a straight line. It means body is accelerating. Gradient is smaller in the beginning and gradient is greater in the, later on. So it covers more distance as the time passes. So this is the data, and at t equals to 0, no distance. T equals to 1 second, 5 meter. T equals to 2 seconds, 20. 3 seconds, 45. 4 seconds, 80. And 5 seconds, 125. If you plot the velocity time graph for this case, then the shape of the velocity time graph will be like this. Body has started from rest and it undergoes uniform acceleration. So this is the velocity time graph for objects which fall under gravity in the absence of air resistance. So this is uniform velocity. The gradient should be equal to 10. Okay, acceleration will be 10. G is 10 meter per second square. So when you calculate the acceleration using gradient of this graph for a free fall motion, the answer should come equal to 10 here. Okay, so this is the body which is dropped from rest and velocity increases uniformly. Okay, what happens when you drop a body, you throw body upwards. When you throw body upwards, of course, you give it some initial speed. Okay, and speed decreases uniformly and it comes to rest at the maximum height. When something goes upward, suppose you have given initial speed of 50 meters second to this ball, and at the maximum height its speed becomes 0. And this is 50. So it's going upward. It slows down, its speed decreases by 10 meters per second every second. So it means it decelerates uniformly. So if we plot velocity time graph for this case, suppose initial speed is 50, and final is 0. Okay, so almost I think it will take around 3 seconds or 2.5 seconds to reach the maximum height. Suppose it takes 2.5 seconds. So what will be the shape of the graph? This way. Why this way? Because velocity decreases uniformly. This is uniform deceleration. Now what will happen next? Of course, ball reaches the maximum height and stops here. So velocity is 0. So this point shows it is maximum height. Then it starts falling backwards. So what will happen? It will have uniform acceleration. Its velocity will increase by the same rate, 10 meter per second every second. Now velocity is 0 here, and now the direction is reversed, so that will come in the negative side because velocity is a vector quantity. So we have to consider the direction. So how will I do? I will continue doing this way, and it will this part. This part shows the downward motion. This is upward motion here, and this is downward motion. And it will hit the ground with the same speed, that is 50. Right? So same velocity. We are talking about velocity, that is why the direction is reversed. Up was taken on the positive side of the graph, so downward is taken on the negative side of the graph. If you draw speed time graph, then speed is a scalar quantity, so don't need to consider the direction. Okay, so how will I show this for speed time graph? Direction is not to be considered. So when I draw a speed time graph for a body which is thrown upwards at a speed of 50, it slows down, okay, and comes to rest in 2.5 seconds, say. Okay, now it falls back. It falls back and speeds up. Now speed increases. I'm talking about speed, so direction is not to be mentioned. So this is 2.5. So what will happen here? This way. What is the difference? This is speed time graph. Speed on y-axis and time on x-axis. Speed maximum while throwing decreases uniformly, 40, 30, 20, 10, 0. Now it falls back and speed becomes 10, 20, 30, 40 and 50. So I did not take it to the negative side of the graph because this is not velocity time. When we plot the velocity time graph for freely falling object, you have to consider the direction. Here the direction is reverse. So this is 0 velocity, and then velocity increases. It is minus 10. Why do we minus 10 is not less than 10? Here minus shows the direction is now downward. Downward we have taken negative, and upward we have taken positive. Okay, so now velocity becomes, it increases 10, 20, 30, 40, 50 in the opposite direction. So that's all. And again, please watch the video again if you don't understand any point, and ask the questions related to it.